So the first thing we need to do is write down a definition. So I'll write it and then I'll give you guys some time to copy it. So the functions f and g are inverses of each other if and only if f of g of x equals x and g of f of x equals x. So if that is true, in this case, we write g as f inverse of x. This is inverse notation for a function. You write a -1 as if it's an exponent on the f. F inverse of x is how it's read. Okay, let's look at an example. F of x equals x plus 2, and g of x equals x minus 2. Okay, we want to know if f of x and g of x are inverse functions. So in order for f and g to be inverses, the composition f of g of x has to equal x, and g of f of x has to equal x. So let's look at f of g of x first. F of g of x. Okay, so all this is, this composition of functions, all this means is we're going to look at our function f of x, and everywhere there's an x, we're replacing that with g of x. So in f of x, we have x plus 2. If we replace x with g of x, we get g of x plus 2. So we would just replace that x with g of x. We know what g of x is. We're given g of x equals x minus 2. So we're going to replace g of x with what g of x is equal to, which is x minus 2. And then we still have plus 2. Combine like terms, negative 2 plus 2 is 0, so we're just left with x. So if we're just trying to make sure that f of g of x equals x, we did that. It does. Okay, we also have to check and see that g of f of x equals x. So in our function g of x, we're replacing x with f of x. So instead of x minus 2, we have f of x minus 2. Now we're going to plug in f of x, which is x plus 2. So we have x plus 2, and then we still have minus 2 after that. Combine like terms, 2 minus 2 is 0, so we're left with x. So g of f of x also equals x. So since both of those things are true, we know that f and g are inverses of each other. So we can write g of x as f inverse of x. So all this is saying is that our function g of x is actually just the inverse of f of x. And that goes both ways. Since these functions are inverses of each other, that also means that f of x is just the inverse of g. So f of x is actually just g inverse of x. They're inverses of each other. Okay, now we're going to look at if we are given a function and asked to find the inverse. There are some steps that we're going to write down in order to do that. So in this example, we were given two functions and we were checking to see if they were inverses of each other. Now we're going to just be given one function and we have to find the inverse ourselves. So steps for finding the inverse of a function. First step, replace f of x with y. It could be any function notation. It could be f of x, g of x, h of x. It could be f of z. Whatever the notation is, you're replacing that with y. Step 2, switch the roles of x and y. Step 3, solve the new equation for y. Last step, step 4, replace y with f inverse of x. Or whatever the inverse notation needs to be. If it needs to be g inverse of x, h inverse of z, whatever's given to us. You just replace y with the inverse notation. Let's work an example. Okay, our instructions, find the inverse of the following functions. Okay, the first function we're going to look at, f of x equals the cube root of x minus 5. Okay, let's follow the steps that we wrote for finding this inverse. First step, replace f of x with y. So now we have y equals the cube root of x minus 5. The second step is to switch the roles of x and y. All that means is anywhere there's a y, we write x. Anywhere there's an x, we write y. So now we have x equals the cube root of y minus 5. Step 3 is to solve the new equation for y. So we need to get y by itself now. Okay, right now our y is underneath this cube root. To get rid of a cube root, we cube both sides. So we're raising both sides to the power of 3. Just like to get rid of a square root, you would square both sides. So now on the left side, we have x cubed. On the right side, the cube root and our power of 3 cancel out and leave us with y minus 5. From here, to get y by itself, we just need to add 5 to both sides. We get x cubed plus 5 equals y. We like to read equations as y equals. So let's rewrite this so that it's y equals x cubed plus 5. We just switched the order around. We didn't really do any math. Now that we have y equals something, we change back to function notation. So step 4, replace y with f inverse of x. So we have f inverse of x equals x cubed plus 5. And that's our answer. Any questions on that one? Okay, let's look at part B of this example. G of x equals x minus 4 over x plus 2. X minus 4 over x plus 2. Okay, first step, replace, well, our step says replace f of x with y. We have g of x, same thing. We're replacing g of x with y. So y equals x minus 4 over x plus 2. Next step, switch the x and the y. So we get x equals y minus 4 over y plus 2. Just switched the x and the y's. Step 3, solve this equation for y. This, in my opinion, is the hardest part of these problems, is remembering back to probably Algebra 1 when you learned a lot of this stuff about how to manipulate equations to solve for a variable. So first step in getting y by itself, we need to get rid of this fraction. So to get rid of a fraction, we multiply both sides by the denominator. So we're going to multiply both sides by y plus 2. Okay, on the left side, y plus 2 times x. We have to distribute this x. X times y is xy. X times 2 is 2x. So we get xy plus 2x on the left side. On the right side, these y plus 2's cancel and leave us with y minus 4. From here, we want to get every term that has a y in it on one side and everything else to the other side. So if I want to move my y terms so that they're on the left side, that means we need to move this y over there. So since it's a positive y, we'll subtract y from both sides. Now, xy minus y does not equal x. Xy minus y does not equal x. In order to subtract or add terms, they have to be like terms, which means they have the same variables and the same exponents on those variables. So since these two terms don't have the exact same variables, this one has an x and this one doesn't, we can't actually subtract. We're just going to have to write this as xy plus 2x minus y. On the right side, the y is canceled, and we're left with negative 4. So we got all of the y terms on the same side, but we need for that to be the only thing that's on this side. Everything else needs to be on the other side. So we need to get rid of this plus 2x by subtracting 2x from both sides. So the 2x's cancel out. We're left with xy minus y on the left. On the right side, we can't actually subtract 2x from -4, so we just write it as -4 minus 2x. Okay, we've got everything in the right spot for what we need. We've got the terms with the y on the left side, everything else on the right side. So since everything on this side has a y, we can factor a y out. So we're basically doing the opposite of distributing. Up here, when we distributed this x to both of these terms, we're doing the opposite. We're pulling something out and we're going to see what we're left with. So if we factor out a y, we're left with x minus 1. And that's still equal to -4 minus 2x. And finally, we have y being multiplied by x minus 1. So to get y by itself, divide both sides by x minus 1. These x minus 1s will cancel and leave us with y. We can't really do any division over here. This is just going to stay -4 minus 2x over x minus 1. Okay, so we've solved for y. The last step is just to replace y with function inverse notation. So we started with g of x. That means y gets replaced with g inverse of x equals this fraction. Questions on this one? Some algebra coming back to you, hopefully.